So now we're done with particle equilibrium in 2D, which is fairly simple. It's not too difficult. Probably the most difficult subtopic in that is defining your free body diagrams correctly and understanding Newton's three laws. Most importantly, Newton's third law, the idea of reaction forces. But now that we sort of are done with that, don't worry. We'll probably in the future. I hope to post more examples of various problems throughout statics at the very end of this series, and continually keep up with that. But as of now, we're going to look at forces and three dimensions, or equilibrium in three dimensions. So as we have the same formula as before. So we have the sum of the vector forces must add up to 0. That's the idea of equilibrium. So that implies that the sum of the forces in the x direction equals 0, the sum of the forces in the y direction equals 0, the sum of the forces in the z direction equals 0. And again, we're only looking at particles, so that implies there's no ideas of torques or moments acting on the particle, since the particle has no dimension. So we're going to look at examples now that are going to be useful, or not useful, or actually useful to understand these topics. So we're only adding one more equation to the problems we're doing now, which is the forces in the z direction. And now we're actually going to look at vectors in three-dimensional space. So if you need a review on how to define vectors in three dimensions, please look at the videos prior or in the early part of this playlist. So we're just adding one more equation, which kind of makes it a little bit more difficult, but I think we'll get through it quite quickly and easily.